Okay. Yeah. So let's talk about multiple integrals, and we recall, sorry, we recall that the limit, pababa ko na lang, that the limit approach by the sums of, hold on, then, by, the limit approach by the sums of f of x sub 1 delta sub 1 of x plus, you remember this one? F of x sub 2 delta sub 2 of x running until f of x sub n delta sub n of x as as delta x approaches 0, and what happened? Your n approaches a very large number. And this will equal to, is equal to what? Is equal to, hello? The definite integral of f of x dx evaluated from a to b. Okay? Now, for a multi-valued function, so multiple integrals meaning we are dealing with multi-valued function. For multi-valued functions, I hope you were able to discuss partial derivatives or derivatives of multi-valued function on your differential calculus class. For multi-valued functions, then we say, ito yung concept sa differential calculus ng derivatives of multi-valued function. We say that f of x1, y1, delta, hold on, delta sub 1 of a, oops, now area, okay, I'll tell you later, plus f of x sub 2, y sub 2, delta sub 2 of a, running until f of xn, yn, delta sub n of a, it's a, oops, okay, as, in this case, it's no longer delta x, but as delta a sub k, or, sorry, delta sub k of a. Delta sub k of a approaches 0, meaning yung the area of the base, and as n approaches infinity. Okay? So, is equal to the double integral is equal to the double integral of the double integral of f of xy dA, that's the differential of area over a region R. And again, this is what you call the double integral. So why is it happening? It's because, say for example, this is the three-dimensional plane, the xy plane, the xyz plane, sorry. And then I will identify, say, a certain cylinder na lang. Oops, pangit. One more. Okay, lang yan. Yan, that's it. So if we want to get the volume of this cylinder, I'll just make this smooth, sorry. So what I'm going to do is I will draw a rectangular parallelepiped. No, so in plane region, what we are doing is we draw, okay, an element that's rectangle. Now, if we revolve it over here, what you will notice to this rectangular element, this one, it will become, what do you think will happen if I revolve it here? Over the axis of revolution. What do you think will happen to this element? From rectangle, it will become what? Hello. It will become, you try to imagine, if this is to be revolved over there, it will become a cylinder. Yes. That is the reason why it is called cylindrical disc or cylindrical shell method, because the region, when it is revolved, the representative element will follow the shape of a cylinder. Kaya they are called cylindrical shell and cylindrical disc. So in this case, what I'm going to do here is I will draw a rectangular parallelepiped. Sorry for the bad drawing. Okay. And then, kulang pa ako ng isa, no? So, ito ay nakaganito. Ano, no? Dapat mahaba to. Okay. And then, dodraw ako ng isa dito. Yan, that's it. Okay. And that is what will happen. So, this is the height of the representative region. And this is the change. Ito, I will shade it yellow. Oh, sorry. One more. Okay, that yellow thing down there, this is the base, and that's the area. I will call it change in A. Yung change in A natin sa ating sums kanina. That is the delta sub K of A. Yan yan. And this is the area of the base. Okay? So this is the region. Yan. And we identified a cylinder. And then to compute for the volume, ito yung ating kukuhaning representative. And then what will happen is that we have to use infinitely many of this kind, so that ma-approximate natin yung ating volume to the nearest possible answer. Okay? So if we use infinitely many of this kind, so liliit ng liliit yung bases natin. So it will it will become thinner. Okay? Mas ninipes, mas liliit. And that's the idea of double integration. Okay? Ito 'yon. So that's the if we want to look for the area is equal to the double integral of the differential of area over a region R. Okay? If we're going to look for the volume, okay? So you can use the triple integral. So double integral muna tayo. And how to execute this? Obviously, you have to take note of the differential of area. Okay? So let me have this example. Say we wish to integrate integral of, let me see, xy dx dy, okay, evaluated from, let me see, 0 to 2y, and then say this is 0 to 3. Okay, oops, one more. It's 0 to 3. Okay, and then how to execute? So you first start at the middle, at the inner. So you get the inner part. Okay, that's it. And then this is what we are going to execute. Now, you have to consider the variable of integration. And in this case, it's x. This is the variable of integration. It's x. Okay? So which means all other variable other than the variable of integration will be treated constant. Okay? So, di ba kapag may constant tayo, we are just throwing it outside the integral symbol? Am I right? Pag may constant, sabi lagi natin, tapon lang sa labas. We just throw it outside. Okay? So in this case, y will be treated constant. So I will just throw it outside. And then I will execute the integration for x. So I only have to integrate x dx. You get my point?
Yes po.
Okay. Yes po. And we continue. You copy y. Then you integrate x dx. So that's x squared over 2. Evaluated from 0 to 2y. And then you have what? I'll just write it here. You now have 1/2 y. Okay? And then x squared is to be replaced by 2y. Again, saan ipapalit yung limit? On the variable of integration. In this case, it's x. So this x shall be replaced by 2y. Then square. Minus 1/2 y. Then 0 square. And then I think this will become 0. So you only have 2 square. That's 4. Okay. The times 1/2, it's 2y. Y squared, y cubed. So therefore, this double integral can now be written as, okay, we can now remove the inner part. We can now remove this, and that is to be replaced by 2y cubed equals 2y cubed dy. All right. Okay, in this double integral, xy dx dy from 0 to 2y and from 0 to 3 is just simply equal to the integral of 2y cubed dy evaluated from 0 to 3. Then we integrate, so you have 2y to the 4 over 4 evaluated from 0 to 3. And then you have 1 half 3 to the 4 is 81. All right, then the rest will become 0. So you have 81, ito siya. This is equal to 81 over 2. Yan. Yeah, 3 to the 4 is 81. One more. Another variation of how you can express the double integral is this. Okay, you have integral of from 0 to a, hold on, from 0 to a dy from, let me see. Okay lang ba? Sige, okay lang. From 0 to square root of a square minus y squared, then x dx. Okay. So what are we going to do first? So when the multiple integrals is written of this form, so you start at the inner part. So kapag ka ganito naman, you know, you can see that the dx and the dy are separated. Okay? They are regrouped. Unlike here, they go along together, side by side. Ito naman, they are separated. So you start at the right side. Dito kayo mag-start. Kuhanin nyo muna to. And then whatever the value of this, you just put it in here. Okay? And then, yeah, integrate. That's 1 half x squared evaluated from 0 to the square root of a squared minus y squared. And then you now have 1 half x, the square root of a squared minus y squared squared. Then the rest will become 0 because the lower limit is 0. Are you still with me?
Yes po.
Okay. Then, yeah, I think I'm done. So that's 1 half a squared minus y squared. And therefore, this thing, this integral, double integral, can now be written as, okay, then copy lang natin yung ito. That's 0 to a. Then we just put this inside kasi this is our integral of x dx from that limit of integration. And then we just affix dy. And we are now ready to integrate again. So you have 1 half times integral of a squared dy is a squared y minus 1/3 y cubed over 3 or 1/3 y cubed evaluated from 0 to a equals 1 half a squared, then y is a, so this will become a cubed minus a, okay, 1/3 a cubed, then again the rest will become 0. All right, and then you can just simplify. 3 times a cubed is 3a cubed minus a cubed, it's 2a cubes. So you have 2a cubed divided by 2 times 3. So you have a cubed over 3. Oops, one more. It's a cubed over 3. And that is the, oops, the double integral. Okay. And done. That's a cubed over 3. One more. Let me see. Let me think of an example. Integral up. Say square root of xy. Square root of x over y dy dx. Dy dx from x squared to x. And then from 0 from 0 to 1. Okay? So first start at the middle, at the inner pala, sorry. That's integral of x squared x square root of x over y dy. Okay? Now, to easily facilitate the integral, you can use the laws of exponent or the laws of radicals in this case. So that's x squared x, then square root of x over square root of y dy. So what is the variable of integration? It's y. Therefore, square root of x can be thrown outside. So tapon natin siya sa labas. X squared x, and then this is square root of y. You can just throw it. You can write it above to make it exponential in form. So y raised to negative 1/2 dy. So you have square root of x, then times y raised to negative 1/2 plus 1, 1/2, and then times 2. And then evaluated from x squared to x. All right. And then you now have 2 square root of x. Y is to be replaced by x. So that's square root of x. So that's y raised to 1/2. Y is replaced by x. Minus 2 square root of x times y is x squared raised to 1/2. All right. Then this will become 2x. Then this will become, y. 2. This is raised to 1/2. So 2 times 1/2 is 1. 1/2 plus 1 is 3/2. X raised to 3/2. And then let's just copy this part. Nag-run pa ba ang ating recording? So you can now erase the inner. So you only have 0 to 1 integral of 2x minus 2x raised to 3/2, then finally dx. And then integrate. Then 2x squared over 2 minus 2x raised to 5/2. Then you just multiply this by the reciprocal of that. Then evaluated from 0 to 1. So you can drop this up. So that's 1 minus 4 over 5. And then the rest will become 0. So finally, you have this, which is equal to 1 minus 4/5 is 1/5. So the double integral of square root of x over y dy dx evaluated from x squared to x, and then from 0 to 1 is equal to 1 over 5. You're still with me? No?
Yes
Yeah?
po.
All right. Thank you. Then I'll just give you one more. Isa pa. I'll do it in trigonometric function. Integral of, let me see, sine x over y and dx dy evaluated from 0 to y square, and then from 0 to pi. Okay lang? I think so. Pwede. Okay. So start again at the middle, at the inner pala, sorry. You get this part. Control V. All right. Then, you tell me how to integrate. Sir, can we throw this, the variable of integration po is x. Sir, there's y here. Can we throw this outside? Sir, like this one, no? Di ba tinatapon natin to sa labas? Ito, square root of x. We throw it outside. Where is that? Where is that? Yeah. Square root of x, we throw it outside because the variable of integration is y. Just like this. That, where is that? Sorry. That y is thrown outside because the variable of integration is x. Yeah. So what about here? Can we throw 1 over y outside? Kasi this is x over y is 1 over y times x. What do you think? Any idea? So that we can easily facilitate its integral. Come on. What are we going to do? You tell me how to integrate this. Okay? Say sine 3x dx. Can I hear someone? Among the boys. Can I hear from the boys?
Negative 1/3 cosine po.
Okay, you remember that, ha? Negative 1/3 cosine 3x plus c. And then, can I hear from among the girls? What about sine 1/3 x dx? Can I hear from among the girls? Why there is 1/3 in front? Why there is 1/3 here?
Sa 3x po.
Okay, so you just get the reciprocal of the 3 because the derivative of 3x is 3. So you get the reciprocal, there's 1/3. Okay, then, can I hear someone from among the girls? Just apply the same technique.
Negative 3 cosine 1/3 x.
That's it. What are you doing with the constant? What are you doing with the constant? You're just getting the...
Reciprocal.
Okay, and can you apply it here? Because y is treated constant. So this y will assume the role of 3 here. Right? Kasi this 3 is constant. And y here is constant because our variable of integration is x, 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 x. All right? You get me right?
Yes po.
Okay.
Yes po, sir.
All right. So can you tell me the oops. Yeah, where am I? All right. I'll just erasing this part. Can you just tell me the integral now, applying this concept that we have recalled? Okay, what is the result? Obviously, it's negative. Obviously, there's cosine. Then you just copy the parameter. And then?
May y po sa unahan.
Okay. Where did that come from?
1 over y.
Okay, that's the reciprocal of 1 over y because 1 over y is treated constant. Then, yeah, evaluated from 0 to y squared. This is the same concept of partial differentiation or the derivatives of multi-valued function. Now, halimbawa, you are differentiating x with respect to y. There's no x here, so you say it's 0. The derivative of x squared in terms of y is still 0 kasi there's no x here. If I put a y, x squared y, so you just copy this x squared kasi that's constant, you differentiate y. That's 1. Okay? Diba? This is what happened during the derivative of multi-valued function. This is the last part of your differential calculus. Okay? And then, we just replace x by y squared. Okay, wag malilito sa kung saan nagpapalit, ha. Laging you're going to look on the variable of integration and that's the variable to be replaced by the upper and the lower limit respectively. So that's negative y cosine x, that's y squared, over y. Then minus, this is negative, so plus y cosine 0 over y. And cosine 0 is 1. So we have here negative y cosine y squared over y is y plus, yeah, y, and this is equal to 1. Cosine 0 is 1. And therefore, all right, we can now replace this by okay, then this is now equal to integral from 0 to pi, then this one, negative y cosine y plus y dy. All right. Then, pwede nyo nang paghiwalayin if you want to. Wait, no. Copy natin sa taas. We're losing out of paper. Okay. Then, pwede na natin paghiwalayin. Negative 0 to pi y cosine of y dy plus y, oops, plus integral of y dy. Alright. Then, ito, madali na. What about this one? What will happen? What are you going to do? Hey, come on. Do you recall the
Sin
process?
Y.
One more?
Negative sin Y.
One more? Improper. It's incorrect. Sorry, improper. It's incorrect. Come on, think of it. There's y outside. There's cosine y. This is algebraic. This is trigo. Algebraic go along together with trigonometric function. They are different kind of functions. What are you going to do? What technique of integration shall be used?
IBP po.
IBP. Go. Okay. Solve niyo siya by IBP. Tandaan niyo pa yung process? UDV plus, ano nga, sorry. UV minus the integral of V du. Last problem na tayo after nyan. So you have, oops, sorry. Let you again, apply the liate. Tama? Alin ang ating u? Or you can use the tabular. Let u equals y. dv is cosine of y dy. du is dy. V is sin y. So you have negative uv minus the integral of v du. V du. And then plus, oops, 0 to pi. 0 to pi. Integrate ko na ngayon. Integrate na natin to. That's 1 half y evaluated from 0 to pi. And then, now have negative y sin y plus. However, the integral of sin y is cosine negative. So, magiging negative ulit. Cosine of y plus 1 half y evaluated from 0 to pi. Then, negative pi sin pi minus cosine of pi plus 1 half pi. And then, sa 0 minus 0 na to. But this will not become 0 kasi cosine 0 is 1. Then, yun na lang. This is 0. This is negative 1. So, you have, why? I get a little excited. I forgot to replace this by pi. This is 0. This is negative 1. So, it will become 1 plus 1 half pi. Then, plus cosine 0 is 1. So, you have 2 plus pi over 2. And that's the double integral of sine x over y dx dy from 0 to y squared and 0 to pi. Okay, last example. This one is a triple integral. 1, 2, 3, then 0. Let me see. 0 to x plus y. Then 0 to x. Then 0 to 1. Let me see. X plus y plus z. dz. dy. dx. Okay. It's a triple integral. So again, we start at the inner part. We get this part, and we are now integrating with respect to z. And I ask someone, you tell me the integral if you really comprehend our lesson. Can I ask someone? Integrate with respect to z. X and y are treated constant. What's the integral?
X plus Y po, nasa labas.
Oops, one more. One more. Should we throw x plus y outside?
Hindi po yata.
Hindi po yata. Kasi this is written as sums. Yung kanina natin, we throw it outside because this is written as product. Like this one, integral of 3x. So, dx. This 3 can be thrown outside. Pero, if it is 3 plus x, dx, wag niyong itatapon to sa labas. I-integrate natin. Okay, this is constant. How do you integrate 3 dx? 3x. What did you do? Yeah, what did you do? To integrate, what did you, if there is constant, what are we going to do with that constant to integrate?
Add po yung variable na ni-integrate.
Okay. Hindi add ha. Baka
Multiply.
okay. Itatabi lang po, no. Lalagyan lang po ng x kasi baka akala natin add na ganun eh. No. Okay lang. So I know what you mean. Okay? So ang sinasabi niya, a-add po yung x, ibig sabihin nun, magtatabi po ako ng x doon sa constant. So that's the idea. Okay? If we are integrating a constant, so we are just affixing, that's the right term, we are affixing the variable of integration to that constant. Okay? So again, we are throwing this outside kasi this is written as product, but if it's no longer written as product, we're not going to do it anymore. Okay? Then we go back to that problem. Where is it? Okay. Okay. Then can you tell me again the result if this is integrated?
xz of c plus y plus c squared over 2.
All right. O yun, at least nagigets nyo na, di ba? So from 0 to x plus y. Can you see the importance of participation? You can easily get it if you participate on the lecture, on the discussion process. Kasi kung nanonood lang, yeah. And then where are we going to replace? We are going to substitute this x plus y to the variable z. Okay. Plus y times x plus y plus 1/2 times x plus y squared. And then I think the rest will become 0 kasi everything contains z. So the rest will become 0. So you have x squared plus xy plus xy plus y squared plus 1/2 x squared. This is 2xy times 1/2 is xy plus 1/2 y squared. Then how many x squared? This is x squared. This is 1/2 x squared. 3/2 x squared plus xy, 3xy plus I think there's another 3/2 y squared. Yeah. Then I will copy this part. Literally copy paste ako ha. Then this is now equal to, we now erase the inner part. Ito. Ito lang gamitin. Then we just replace it by this. Control C. Okay, modify ko na lang later. So that's dy dx. Dalawa na lang. dy dx. And then, come on. Kuhanin ulit natin yung gitna. Inner part. Right? Then, we continue to integrate. This time, it's with respect to y. Come on. Can I hear someone? There is no y here. So this is treated constant. So you just affix y. 3/2 x squared y. There is y here. So yung 3x, yun yung pwede nating itapon sa labas. So that means tapon sa labas. Ano bang ibig sabihin ng itinatapon sa labas? Kinakopy lang natin. And then, ini-integrate natin yung y. Is it clear? You're still here with me? Okay. Can you still hear me?
Yes
okay.
po.
Okay, good. And then for the last part, 3/2 y squared. So we will integrate. So that will become 3/2 y cubed over 3. And then evaluated from 0 to x. Okay. Equals 3/2 x squared. Y will be replaced by x. So 3/2 x squared times x plus 3 times 1/2, 3/2 x, and then y squared, x squared, plus 3/2, or, why is it, you can cancel this out now. So that's 1/2. Yeah, it's 1/2. 1/2. Then y is to be replaced by x cubed. Then the rest will become 0. And then this is 3/2 x cubed plus 3/2 x cubed plus 1/2 x cubed. So this will give you 3, 6 plus 1, 7/2 x cubed. The next, copy ulit natin to because this is now equal to lang. Integral from 0 to 1, this one. 7/2 x cubed dx. And we're almost done. Integrate x to the 4 over 4 evaluated from 0 to 1. And the result is 7 over 8. And that's the integral of this. That's the triple integral of x plus y plus z dc dy dx evaluated from 0 to xy. So 0 to x plus y, 0 to x, and 0 to 1. Yeah,